Hello viewers, welcome to my YouTube channel Bright Mind EduPoint, and in today's video I'll be discussing on the topic of blending of aggregates. So what is actually blending of aggregates? So blending of aggregates, it is defined as the process of mixing aggregates from two or more different sources so that one can obtain the desired gradation, and the process of obtaining the desired gradation is nothing but called as the blending of aggregates. This exercise is done by highway engineers to ensure that they get the good quality bituminous mix with respect to workability and volume stability. So the next point is the situation where the aggregate blending exercise is to be done, because mostly it is seen in the site that the aggregates from one sources are usually used for making the bituminous mix. So aggregate blending, this exercise is usually done when aggregates from the known source or nearby source is unable to provide required gradations as per standard specifications. Okay, so whenever you are constructing a pavement and you want to design a bituminous mix, and if you see that the materials from the nearby sources or from the source which you have ordered, it is not able to provide the desired gradation, in such situation your aggregate blending exercise is must. Second is when the aggregate from any source which provides the required gradation, but it won't be able to supply the aggregate for a maximum amount of time. In such situation, this exercise of aggregate blending will be very much essential. Now, why aggregate blending is done? Okay, so basically in aggregate blending, okay, it is done so that we'll get the densely graded aggregates or densely graded mix. So blending of aggregates is done so as to ensure one gets densely graded aggregate or densely graded mix. Why? Because your densely graded aggregate or mix, it ensures high frictional resistance, greater area of load transfer, and improve stability of the mix. For all this reason, the exercise of aggregate blending is very much important. There are various methods of aggregate blending. The common which are mostly used are trial and error method, graphical method, and Rothfuss method. Now this graphical method and Rothfuss method are extensively used. Graphical method is usually employed when you have to mix aggregate from two different sources, and Rothfuss method is usually adopted when aggregates are to be mixed from more than two sources, maybe 3 or 4 sources. So in that case, this Rothfuss method is considered. Now firstly we'll discuss about the trial and error method. So basically in this method, trial and error method, the aggregates from the various sources are mixed in various proportions and different trials, and this process is continued until a given trial or any trial gives a satisfactory results in terms of the standard specifications. So basically in trial or error method, we usually employ this formula, that is P is equals to capital A into small a plus capital B into small b plus capital C into small c, and it goes on. So the number of sources of aggregates, the formula changes. Your P stands for the percentage of material passing a given sieve for the blended aggregates ABC. Capital ABC indicates the percentage material passing a given sieve for each aggregate ABC, and small ABC, it indicates proportions in decimal fractions of aggregate ABC that is to be used for making a blended mix. So if I simplify this, now suppose if I want to find out the percentage of material passing 4.75 mm sieve. So I have to consider the aggregates from source A, source B and source C, or the n number of sources which are available with me. I have to decide a proportion between them, maybe 40, 30, 60, 50, 50, 0 or 10, 40, 50 and so on. We have to mix them and we have to find out this value of P, and then this value of P will be compared with the standard specifications. If it satisfies the standard specification, the trial is stopped. If the standard specifications are not met, the trial is continued until the desired gradation is achieved. Now the next part is the steps that is usually involved in trial and error method of aggregate blending. So firstly, we have to obtain the required data. Required data means we have to find out the percentage material passing given sieve sets from various different sources that we have considered. Then we have to select a target value for the trial blend. Okay, so target value is nothing but the standard specifications, which will depend upon the type of mix that the one is going to prepare. Then we'll determine the initial proportions for the blending. What amount of proportions that we have decided initially. Maybe suppose if we have two sources of aggregates, we are deciding to mix it in 40, 30, 60, 30 and so on. That is the next step. Then we'll calculate the combined gradation as per the given formula which is discussed, and then we'll compare that combined gradation with the target value. So there is an example relating to the trial and error method. So there are different sieve sizes provided to us, that is 9.5, 4.75, 2.36, 1.18, 0.6, 0.3, 0.15 and 0.075, and the aggregates from two sources, that is source A and source B. The percentage of material passing through these different sieve sizes are also mentioned. So for aggregate A, if I see for 9.5 mm it is 100% passing, for 4.75 90% passing and so on. And similarly for aggregate B also, that is source B, percentage material passing through 9.5 mm for 4.75 mm. This data is available with us. The standard specifications or target value is also given to us. So now by using these three data, we have to firstly find out which is the best trial or we can say the best proportions which will give us the best aggregate mix or aggregate blending. So the first trial, what we are doing, we are taking 50% of aggregates from source A and source B. So the proportion for the first trial we have taken is 0.5 for this aggregate source A and 0.5 for the aggregate source B. We'll multiply with each sieve sizes and we'll see whether the proportions that we have selected will be meeting this target value, yes or no. So for the first trial, since the proportion was 50% each for both aggregate sources A and B, so the blend, if I see, it is 0.5 into 100 plus 0.5 into 100. The proportion is 50% for both the aggregate sources, and 100 is nothing but the percentage material passing the particular sieve. So if you see in this particular case, the aggregate from source A and source B as well, it is passing 100% corresponding to 9.5 mm sieve. So similarly, I have taken the value of both the percentage material passing 9.5 mm sieve and the proportion, and multiplied with the proportions that has been initially selected. Similarly, it is done for all different sieve sizes. So, and the results are calculated. So for 9.5 mm the blend is obtained as 100, for 4.75 95, for 2.36 65, for 1.18 47.5, for 0.6 25, for 0.3 mm 16.5, and for 1.15 it is 12, and for 0.075 it is 5. Now if you see the specifications corresponding to sieve size 2.36 mm, it is not satisfied. How we can conclude this? Because whenever we are mixing the aggregates from different sources in trial and error method, our aim is to obtain this blended value nearer to the midpoint of the specification. Now suppose in case of 4.75 mm, the specification is given to us is it should be between 80 to 100%. So the midpoint of this comes out to be 90 and our blend comes out to be 95. So we'll say okay, this trial is okay for 4.75 mm sieve. But if I look for this 2.36 mm sieve, okay, so the target value, it is around 67, and I am only getting this value, sorry, not 67, it is something around 82.5, and I am only getting 65, which is the minimum value. So this trial is will not give the sufficient results. So hence we have written here, since the blending aggregates satisfy minimum value for 2.36, we have to revise the proportions of the aggregates from the source A and B, and this is done so that we can get the blended aggregate of each size nearer to the mean target values. So keeping this in mind, we'll take a next trial, and in next trial we'll consider the 40% proportions from the aggregate source A and 60% of proportion from the aggregate source B. The same steps are done again here, just in case of 0.5 for aggregate source A it is 0.4, and in place of 0.5 it is 0.6 for aggregate source B. Similarly, the blend is again calculated and the values are 100, 96, 72, 55.6, 29.4, 19.6, 14.4 and 0.6 for various sieve sizes, that is 9.5, 4.75, 2.36, 1.18, 0.6, 0.3, 0.15 and 0.075 mm. So even in this trial, if you see that most of the values are satisfied. Even if we look for 2.36 mm, the aggregate blend value is not almost near to the middle of the target, okay, or middle of the specification, but it is not also the minimum. It has improved. So we'll try in the next trial, we'll try to achieve a value which is more nearer to the target value. So we'll take a third trial, and in this third trial we'll mix the aggregate in 30-70 proportion. So 30% of the aggregates from source A will be taken and 70% aggregates from source B will be taken for preparing the blended mix. So again the same procedure is repeated, and the blend using the proportions of 30-70 is employed, and the blend for various sieve sizes are found out, which comes out to be 100, 97, 79, 63.7, 33.8, 22.7, 16.8 and 7 corresponding to sieve sizes 9.5, 4.75, 2.36, 1.18, 0.6, 0.3, 0.15 and 0.075 mm respectively. Now if you see that the blended aggregates value that we have obtained, they all are very much nearer to the mean value of the target values. This is 100 only. The midpoint of this basically for 4.75 mm sieve is 90 and we are obtained 97. For 2.36 it is around 82.5 and we have obtained 79, so very much closer. For this it is 60, we have obtained 63.7. For this it is basically 42.5, so again we have obtained 33.8. For this it is 47, which comes out to be 23.5, so we have obtained 22.7. For this it is 23, which is around 11.5, so we have obtained 16.8. For this is 12, which is should be the mean value should be 6 and we have obtained 7. So all the values of the blend that we have obtained are very much nearer to the mean value of the specification. So hence we'll say that this proportion, that is 30% proportions from the aggregate source A and 70% of the aggregate source B will give us the good mix of the aggregate blend, and it will also give us the good quality of bituminous mix. So finally we'll write the answer that the proportion of aggregate A that is to be used for making the blended mix is 30 and proportion of aggregates from source B to be used for making a blended mix is 70. So that was all from the today's lecture. If you have liked the video, please hit on the like button, share it with your friends and subscribe to our channel for more videos related to various topics of civil engineering. Thank you.